All right then, using the information, what is the distance to the nearest centimeter in the triangle at the right, the distance x? So we look at the picture, we see it's a right triangle, which means we have the hypotenuse. We have a reference angle here of 30 degrees.
So we're going to use sine.
So we're looking for the opposite side, and we have the hypotenuse.
O
O
over H.
over H. So we need sine. So we're going to have sine theta, which is 30 degrees, equals the opposite side, which is x, over 30 centimeters, because that's the hypotenuse. Okay? Now, we're going to solve for x, so that means I just multiply both sides by 30 centimeters. So I have 30 centimeters times sine 30 degrees. And if you know sine 30 degrees times 30,
Sine 30 degrees. Just put 30?
sine
by
30, you need to be in degree mode on your calculator. In this class, you'll always be in degree mode.
15.
The answer is 15,
Yeah.
what?
Centimeters.
Centimeters.
What's green mode?
Yeah, I got no.
Oh, degree mode.
Degree mode.
I heard green
Oh,
mode. I'm
yeah, I
like,
heard
what?
green.
Degree mode, 15 centimeters. Okay. How far north and east? So suppose Alex is navigating using a compass. She starts walking at an angle 60 degrees north of east. So walks a total of 100 meters. How far north is she from her starting point, and how far east? So what we're going to do is start by drawing a picture.
Okay.
So here's her starting point at the origin. This is a pretty common problem here. Now she starts walking at an angle 60 degrees north of east. That means if she was walking due east,
It's northeast.
great. But now she's walking north of that, okay? So 60 degrees north of east means she's walking like this. That's a 60-degree angle right there, okay? So our compass means this is north and this is east.
Thank you.
All right, now she walks a total of 100 meters. So this distance right here to this point is 100 meters. Notice how I made that a vector. That's a displacement vector. How far north is she from her starting point? How far east? Okay, so what we're going to do now is make a different displacement vector. So we're going to go directly across here.
Don't you need your arrow? Over top of 100.
So watch what I do. We're going to go directly across, and we're going to say, what if she had walked directly north to the same point right there? That would be like y. That's supposed to be a y. And then walked directly east from there. Okay? And I'll call that an x.
Does that mean that inside angle's 30?
Okay, so yeah, now the way that I drew this, the inside angle is 30 degrees. Okay? Now, that's just the way I drew it. Maybe you thought, well, what if she walked east first? So that would be to here, and I call that x, and then she went north, and that's y. Okay? It doesn't matter. In both cases, there's a right angle sitting right there,
And then it's 30 degrees.
and in the other case, there's a right angle sitting right there. In both cases, the hypotenuse is still 100 meters. In both cases, we have an angle that we can use. Okay? There's a 30-degree angle sitting right here, and there's a 60-degree angle sitting right here. Both triangles are 30, 60, 90 right triangles. Okay? So it doesn't make any difference which way you drew it. Right? We're still going to get the same thing because what I've created is a rectangle. This x is the same as this x, and this y is the same as this y. All right?
Yeah.
Okay. So now let's see if we can solve it. We know the hypotenuse is 100 meters. We can solve for x first. What should we use?
So we're trying to find.
Sine, because we have the opposite and the hypotenuse.
We
For
don't
the
have-
top left one.
Okay, so sine what?
Sine 30.
Sine 30 degrees equals x over 100. So to solve for x, we just multiply both sides, and this is meters. Solve for x by multiplying both sides by 100. So we have x equals 100 meters sine 30 degrees.
50.
It is 50 meters. All right. Now we're going to solve for y. What are we going to do?
Y would be
Cosine?
Okay. So we're using this y right here, and we're going to call that the adjacent. So that would be cosine
30 degrees
30 degrees,
equals y over 100.
y over 100 meters. Solve by multiplying both sides by 100, and you get y equals 100 meters cosine 30 degrees. What do we get?
I gotta remember how to do this.
I got it. Uh, 86.6025.
Okay, now this is meters, but can we keep all those digits?
No.
Okay, how many can we keep?
2.
2?
Or it just, it doesn't matter because we don't have
This was the number they gave us, 100.
So
we can keep 3, so it'd be
We can keep
86.6.
1?
1.
Oh, because
Oh.
We don't know if these two digits here are measured or
so
not.
it's
That's 1.
86.6.
We can keep one digit.
90.
90 meters.